Okay, this is going to be the first lesson in Unit 6 in Algebra 2. We're going to talk about factoring, difference of cubes. We're going to talk about some other basic stuff involving polynomials. When you have a difference of cubes, a little bit different than difference of squares, it's okay to have a plus sign there, okay? All right? Unlike with square roots or even powers, you cannot. Now, there is a pattern to this, okay? There is a pattern. It is a 2 by 3. Whatever sign is here goes there. Whatever sign is here is the opposite sign. And this is always positive. Okay? So it's a pattern. Now, here's how you get these terms. You take the cube root of both parts. Okay, so this would be a plus. Cube root of 8x cubed is 2x. Cube root of 125 is 5. Okay? This would be a minus sign. Okay, to get this term, this times this has to give you that. So that's got to be 4x squared. If you don't have good multiplication skills, you always divide 8 by 2 and give you 4. This times this has got to give you the last term. Once again, if you don't have good multiplication skills, divide those. Gives you 25. To get this term, you multiply these two things. So 2x times 5 would be 10x. And that's what goes in that spot, and that's how you factor it. So you have to know the pattern. Okay? So here, all right, since that's a minus, opposite, always positive. Okay? Take the cube root of this. Cube root of this. Cube root of 27x cubed is 3x. Cube root of negative 64 is 4. 3x times what would give me that? It would have to be 9x squared. 4 times what would give me 64? It would be 16. Get that middle term, multiply those 4 times 3x, which is 12x. Okay? And that is the factoring of that. Okay? All right, let's look at this one. Okay? All right. All right, so I got a minus, plus, plus. That's a 1 there. Cube root of 1x cubed is 1x. Cube root of 216 is 6. Okay? All right? You can also just play around in your calculator, multiply them 3 times, and that's what you would get. Okay, 1x times this has got to give me that, which would be 1x squared. If I divide 216 and 6, you get 36. 1x times 6 is 6x. Okay? All right. One of the key things is that this is easy to solve. This, you're going to have to use the quadratic formula. Okay? All right, when you go to solve it, just so you know. Okay, we're not doing that right now, but just so you know. All right, so you guys go ahead and practice those. All right, converting from solutions to factors. Converting from factors to solutions, solutions to factors. So here's something you have to understand. What you're basically doing here, and we did this, all right, if you go to solve, you would add 7. So it's x equals 7. So the fast thing to understand is that when you convert those, it's x equals to this. These are opposite signs. If you just want something very quick, you have to understand those are opposite signs. So that's that. This would be x equals negative 4. Okay? Now, the solution for that, you could set it equal to 0. That'd be 2x equals 1 divided by 2. That's going to be x equals 1/2. Okay? This would be x equals negative 3/4. This would be x equals negative 1/5. If you set that equal to 0, it's just going to be 0. So x equals 0. Okay? So you have to know how to go from solutions to factors and factors. If you need to set these equal to each to 0, all right, do it. Okay? And it might be some mental math in there. Okay? If you want to go faster. Now, to convert back to factors. So the idea is a factor has a parenthesis with a plus or a minus in between it. So the idea here is this is a factor would be x plus 8, the opposite sign. The factor for this would be x minus 12, opposite sign. Now, for the fraction ones, this would be x plus 1/6. Now, we don't really like to write that like that, so we move that 6 there. So that's 6x plus 1. And if you go to solve that, if you wanted to see what that looked, 6x plus 1 equaling 0, So this is a little bit of mental math that will speed up the process for you. Okay, so what would this one be? That would be x minus 1/7 or 7x minus 1. The factor for x equals 0 is just x, just something you're going to have to know. And this one would be x plus 3/5, move the 5 up, 5x plus 3. Okay, so you want to be able to convert from solutions to factors. Okay, so you guys go ahead and pause your video and go ahead and complete these. All right, end behaviors. Let's talk about this. Every polynomial falls under one of these shapes. This is going to be odd positive, because that's odd slope positive. This is going to be odd negative. This is even positive. And this is even negative. Okay? Now, all right, we did this with domain and range. Let's label our arrows. This would be a right arrow going up, a left arrow going up. This is a right arrow going down, a left arrow going down. We did this with domain and range, okay? All right, this is a right arrow going down. This is a left arrow going up. This is a right arrow going up. This is a left arrow going down. Now, here's the idea. Every polynomial, if you look at the coefficient with the exponent, okay, we care about whether the coefficient's positive or negative if the exponent is odd or even, okay? It will trace back to one of these four pictures, okay? So what do I mean by that? If I had something like this, if I had something of this nature, and they wanted to know what the end behaviors were, okay? And what end behaviors are is you'll see something that there's a number of ways to write them. Okay? You will see them as x approaches infinity, y approaches blank, x approaches negative infinity, y approaches blank. They'll just ask, what are the end behaviors? Okay, that would be a question, so that's one way to ask it. Here's a second way. I don't think we're going to see a lot of this, but when you get to pre-calculus, they'll say the limit as x approaches infinity, the limit as x approaches negative infinity. Now, this actually isn't that hard. What you have to do, and let me just use this example. Okay? You look at your biggest exponent term. So you look at the biggest exponent term. Okay? Now, is this even or odd with the exponent? That is odd. And then I look at, is the coefficient positive or negative? It is negative. So, this is the odd negative picture. Okay? All right? So I'm going to go ahead and go over to this. So this is the odd negative picture. So negative, positive, positive, negative. All right. So here is the concept. As x approaches infinity, well, if you look at that, that's that one. Well, what's the y value? That is negative infinity. As x approaches negative infinity, that's this one. What is the corresponding y value? That is positive infinity. How would you answer these? If they ask for the end behaviors, the right end behavior is negative infinity. The left end behavior is positive infinity. It's just the answers to those. The same thing with this, okay? All right, this would be negative infinity, and that one would be positive infinity. So all you got to do is trace back to that picture and look at it, okay? So It says find the end behaviors of the following functions. So my biggest exponent term here is this one. This is even exponent, positive. So what does that picture look like? It looks like this. Positive infinity, positive. Negative infinity, positive. Okay? So the right end behavior is positive infinity. The left end behavior is also positive infinity. Okay? All right? So you can write it like that. You could write it as x approaches infinity, y approaches positive, x approaches negative, y approaches positive. Either answer I will take. Okay? So what's my biggest exponent term here? This. This is going to be odd exponent and a negative coefficient. So what is that? That's this picture. Okay, so a couple ways you can label that. The right end behavior is negative. The left end behavior is positive. You could write it as x approaches infinity, y approaches negative infinity, x approaches negative infinity, y approaches positive. Because remember, this is the x, this is the y. This is the x, this is the y. Okay? Now, you gotta be careful on this one. My biggest term here, not the first term, it's that one. That's gonna be an even exponent, and that's gonna be a negative. Okay? So what does that mean? I got this picture. Negative, negative, positive, negative. Okay, so the right end behavior is negative infinity. The left end behavior is also negative infinity. Or you can write it as x approaches infinity, y approaches negative, x approaches negative infinity, y approaches negative as well. It's up to you on how you want to write it. Okay? Just be able to understand both. Okay? Go ahead and try these on your own. All right. Synthetic division. Let's talk about synthetic division. Okay? Synthetic division, okay, it's a way to divide polynomials. Why do we do it? It will determine if the number in the half box is a solution. If it is a solution, then converting the solution will be a factor of the polynomial. It helps simplify the polynomial and can help evaluate the polynomial using something called synthetic division, which you're going to do a little bit next year. I don't know if we're going to do that later in this unit. We might. Okay. Now, what is synthetic division? Okay. Use synthetic division to divide the polynomial. Now, here's what you do. It's actually pretty simple. Whatever you're dividing by, if you set that equal to 0, that would be x equals negative 2. That number goes in the half box. Okay? Now, you take your biggest exponent, which is x to the 4th. You have to account for all of the exponents running down to the number. Now, what I put here is I put the coefficient. So for this is 2. Now, for x cubed, as you can see, there is no x cubed, so I put 0. Then I put negative 5 for the x squared, for the x and the number. Now, what I'm going to do is I always put a plus 0 here. So 2 plus 0 is 2. I take this number, I multiply by the number in the half box. 2 times negative 2 is negative 4. 0 minus negative 4 is negative 4. And I multiply that number in the half box, it gives me 8. Negative 5 plus 8 would be 3. I take that number and multiply by the number in the half box, that's negative 6. 5 minus negative 6 is negative 1. I take that number and multiply that. Negative 1 times negative 2 is positive 2, and I get 0. Now, here's what's important. If you get 0, what this means is the number in the half box is a solution. Okay? It also means what you divided by is a factor. That's probably the most important thing that comes out of that. Also, conversely, if it's not 0, that's not a solution, and that's not a factor. Okay? Now, here's the other thing this does. If it is x to the 4th, now this becomes x cubed, this becomes x squared, this becomes x. This is the number, and this is the remainder. And we'll talk about how to write that in a second. So what I got here is I got 2x cubed minus 4x squared plus 3x minus 1. So by dividing that, that's what basically is going to happen. Okay? All right? So what's my number in the half box here going to be? It's going to be 4. My biggest exponent is x cubed, x squared, x number. X cubed would be 5, x squared would be 3, negative 7, 8. Put a plus 0. 5 plus 0 is 5. 5 times 4 is 20. That is going to be 23. Okay? 23 times 4, 92. That's going to be 85. 85 times 4 is 340. This is 348. Now, a couple things you know. 4 is not a solution of this. X minus 4 is not a factor. Now, let's talk about it. This is x. It's going to be x squared, x number, remainder. So what I got is 5x squared plus 23x plus 85 plus 348 divided by whatever you divided it by, that's what goes there. And that's how you write the remainder, okay? Let's do one more of those. Okay, so I would want to solve this. That would be x equals 3 halves. That number goes in the half box. I got x cubed, x squared, x a number. So that's going to be that, negative that, positive 15, negative 14. All right, 10 plus 0 would be 10. 10 times 3 halves, so 10 times 3 is 30, divided by 2 would be 15. 2. 2 times 3 is 6, divided by 3 would be 3. That's going to be 18. 18 times 3 is 54, divided by 2 would be 27, and that would be 13, okay? So what we know is 3 halves is not a solution for this. So this is going to be x squared, x number, remainder, okay? So I got 10x squared plus 2x plus 18 plus 13 over 2x minus 3, okay? All right, so what I want you to do is to finish this lesson by practicing these, and what we're going to do is we're going to use synthetic division to help us find solutions and factor in the next few lessons.